In this video, we're going to talk about tibble and readr, two of the core tidyverse packages that are loaded when you load the tidyverse. Tibble is for better data frames, and readr is for reading in your data. So let's get into it. What are tibbles? At a basic level, tibbles are data frames. The only difference is that they make them a lot easier to work with. For example, to create a tibble, instead of using data.frame, you use the function tibble. So here's a tibble. TB is tibble, x equals 1 to 3, y equals abc. Notice that this is how it prints out. It says explicitly that it is a tibble. It has 3 rows and it has 2 columns. The names of the columns are x and y, and they're of class int and character. Now, that character thing is particularly important. It's saying that the tibble function, unlike data.frame, doesn't mess with your names. In other words, you never have to type strings as factors equals false because the tibble function will not create a factor vector for a character vector. You can ask R what class TB is, and there you see that it is actually the data frame. So why would you want to use tibbles instead of data frames explicitly? Well, at a first glance, tibbles have much nicer print methods. In other words, when you actually just look at them, they look a lot nicer. One of the ways they look nicer is that they never overflow your page. So instead of printing out, say, 1,000 rows, it will only print out, say, the first 10 rows by default, and it will say that there are more rows that it just hasn't printed. The same thing will happen if it overflows because the number of columns is too wide. I just don't have an example of that here. Now, there's also a function called glimpse, which is really useful to just kind of take a str-like look into what the data frame looks like. So instead of seeing it vertically, you can now see them horizontally, which is a little bit nicer if you have a whole bunch of variables. Unlike data.frame, tibble also has rolling evaluations. What I mean by that is, let's suppose that you want to create a data frame with 2 columns, x and y. X is equal to the integer vector 1 to 3, and y is simply equal to x plus 1. The problem with doing this with data.frame is that it does not roll the evaluations. So in the second part, where we refer to x right here, data.frame does not know that x was created in this previous part because the evaluations don't roll. By contrast, if you use the tibble function, tibble does know how to do that kind of thing, and tibble rolls the evaluations, which is a really convenient thing to do. If you already have a data frame and you want to convert it to a tibble, use as_tibble. So for example, if I create a data frame like this, x is 1 to 2 and y is true false, I can convert it into a tibble using as_tibble, and then it will have all of the nice print methods and so on. Occasionally, you'll have some functions that don't like working with tibbles. Usually these are older modeling functions. And if this is the case, just convert them right back into an ordinary data frame with as.data.frame, like this. Now, in addition to tibble, there's another function called tribble that populates the elements of a tibble in a slightly different way. For example, with tibble, like data.frame, when you enter the vectors, they're entering by column. So here I have tibble x equals 1, 2, that's the first column. Y equals true, false, that's the second column. Occasionally it's useful to enter the entries by row, especially when I'm using them for examples. So I could do this with tribble. So this is exactly the same tibble, the exact same data frame that's created, but now I'm specifying it in a really readable way down the columns themselves. So it makes it a lot easier to read if I just want to define a tibble on the fly to use tribble. I give the column headers with this tilde to begin with, followed by whatever the name is. So just x and y, or whatever variables you have. So that's tibble. What about readr? Readr contains functions to read in datasets. So here's an example. I'm going to create a temporary file called file. So the variable called file here is simply a file name that points to a temporary file on your computer that after you restart R, this file is going to be deleted by your operating system. And what I'm going to do is I'm going to save a CSV file into it. So to start, I'm going to create a data frame with tibble, and I'm going to use the write.csv function. The object that I'm writing is called tb, the name of the file is file, and then I don't want to save the row names. Usually you don't want to save row names, and if you set row names equals true, which is the default, you'll have a useless column on the far left side that simply indexes the rows 1, 2, 3, 4, and so on. Now there's a function called file.show, which is useful to look at a file to see generally what it contains. An alternative to this may be something like open it up in Excel or some other spreadsheet software. But file.show usually gets the job done. The standard way to read CSV files into R is with read.csv. So I say read.csv and then I tell it the file name. I can then look at what it is by piping that into the str function. So it says that it's a data frame. It has 3 observations of 2 variables. The variables are called x and y, but notice that y is a factor. Read.csv by default is going to mess with your variable types, just like it's going to mess with your variable names. So one of the changes in readr is that the readr function is not going to do that kind of thing. All readr functions are going to output tibbles, and the functions that do the reading in readr use underscores instead of periods. So instead of seeing something like read.csv, the readr equivalent is read_csv. Let's take a look. There are typically three kinds of specifications that you would use for read_csv. The usual way we've used it up until now is with the file name passed in as a character. So data.csv, or maybe you have a path to a particular data file on your computer. Another way to do it would be straight off of the internet. So if you know of a CSV file that is on the internet and you know what its URL is, this is a URL, you can just put the URL in there and it will just read it offline directly. Note two things about that. First, of course, you have to be on the internet. And second, after you restart your R session, you won't have that data on your computer because it's not actually saving it to your hard disk. It's only saving it to your local memory on your computer. Now, read_csv also allows for something else, which is reading in a character vector directly that is in the CSV format. You can't do this kind of thing with read.csv, but you can with read_csv, which is very useful in understanding how it's going to work in different scenarios. For example, with read_csv, like this, the result would be a tibble, which is exactly what you want. It has 2 rows, it has 3 columns, and the names of the columns are, of course, on the first row, which is exactly what you would expect in a CSV file. Now, read_csv is also going to do things like ignoring white space and so on, so that the ultimate tibble that is read in is exactly what you want. In some cases, you get a CSV file that doesn't have a header associated with it. When that happens, you get the data on the first row, and that data on the first row becomes the column headers, which is of course not what you want. In that circumstance, what you can do is you can say call_names equals false. What it will do is it will give them default names that look like big X1, big X2, big X3, and so on, all the way down the line. And then you need to change the names later according to whatever those variables actually represent. Alternatively, you can also specify the column names. Instead of saying false, you can actually just give it a character vector A, B, C, and it will know that those correspond to the column names of the resulting tibble. Lastly, if you have something else like an Excel spreadsheet, what you may want to do is you may want to look to the readxl package. The readxl package is going to have several useful functions that can read in XLSX files and point to particular worksheets of those XLSX files so that you can target exactly the worksheet that you'd like. As an alternative to that, you could also open Excel, or you could open some other spreadsheet application like Numbers, and then you could export it as a CSV file. That's also a very common thing to do as a data scientist. So that's tibble and readr.